Hello everybody, my name is Anand and in this video I am going to be giving you a code explanation of the game for Infiltration. Okay? If you haven't watched the game demonstration of it, I highly recommend that you go ahead and watch it, even though it won't be helpful much, but then again it is still very helpful. Okay? So as to know what exactly it does. Okay? Oh, and I should mention I've used that mysterious DLL file called Windows Voice here. Again, I will be putting out a separate video later on to explain exactly how this Windows Voice DLL file was generated. Okay? But let's get back to this game first, okay? Okay, let's see. Oh, and I think I just realized something. And clear out some of these using directives. And here's a handy thing you can do to move to a separate file. Many of these files will be fairly tiny, but that again doesn't make a difference for us. Okay? I just like to keep things separated out as much as I can. Okay? Yeah, A character. If you're wondering what A means, it's my general convention to keep the thing that abstract classes starting with A. Like there is I enumerable, I enumerator, I read only dictionary. Like so I keep it A character. Okay? For abstract. Now this is actually the common code between the player and the enemy, which I just recently segregated. Yeah. I just very recently segregated it out. Very recently, isn't it? Right now. Okay? Oops. See. Cleaned up first. Tomato. And that should be good. Okay? So let's get started. We are explaining the code of A character. Here we have a lot of abstract classes. I mean abstract properties and 3 abstract functions. How many abstract? What is 5 abstract properties? Okay? One moment. We have to surround these serialized fields with these pragma warning disabled, or else the warning system will keep shouting at us. You have not initialized these. They're always going to be that default value, so they'll keep shouting at us till we don't. Yeah, I'll do it. Bye. That was not very helpful for me over here. And yeah, that's it. That's all I did. That's enough. Now, any warnings? We know warnings are sometimes very useful when you take a look at them, but sometimes, in some of my earlier projects, there are like many warnings, and I really don't know which one to pay attention to. So I usually click clear on play to only show the warnings that pop up while in play mode. Okay? Now let's get back. We have a mind mat for material. Yeah, but we have to keep it mind mat. Okay? Dir for direction 6-sided and dir std for direction 4-sided. This is just a thing I gave. Oh, sorry. Only 4. That one is not abstract. That used to be abstract, but now it isn't. Okay? And we have all the enemies, though technically all the enemies have only one enemy, and that's player. Oh, sorry. And it's called player. Because having a conflict, that's the reason. Okay? And then we have 4 abstract properties: my material, direction 6-sided, and direction 4-sided. So I call it dir and dir std for direction and direction standard. And then all the enemies. A character. Again, an array of characters. So technically many of these aren't arrays. Never mind. Then we have a on die, on hit edge, and on self hit tile. So you can't really say I'm hitting a tile. You have to say when it is on its own self type. So if it moves over its own self type, on, this is the, how do you say, usually you have on update or on die, on hit edge. That's why this first on means this is a function which you have to call when the thing after it happens. So on, when it is on a self type. Okay, that's why it's this is not a type I thought through it. I really can't find anything else for it. So if you can, please tell me. Okay. Then we have a few protected ones where player can enemy can access. Okay. Speed, score display, life slider, life display, time to collapse, and score till change equals. Hold on a minute. Oops. This isn't used anywhere else. Mistake. Sorry. That's only for the player. Score till change. I'll explain what that means in a moment. Okay. Then we have a score, obviously. Last collect time, which gives you last collect time, and last collect time, and set, which is also required for the starting bonus over here. Okay, we'll get to all of that in a moment. Okay, then we have the life slider, which just gives you the life slider. Much easier if you ask me. A score, a life, a last collect time, direction and direction STD. Direction and direction standard, and then we have start underscore. If you may be wondering what that means, it's because let's not make that virtual anymore. The reason for that is very simplistic. What happens is, if you in normal functions, if you are inheriting it, then you have to call your parents start and your very own start. But the thing is, it gets called twice. Why? Because first it's called by Unity's scanner. It just passes through all the functions, and I've seen it happening once, so there might be a few changes. But then again, we'll keep it like this, and then first it will call this, and then it will call the player's start or the base class or the derived classes start, which will call this start. So it gets called twice, which, well, in certain cases might be a loss of computation, which might be computationally expensive. Okay, so don't do that, at least not for these functions. But here I've made them protected, sealed. It's an override. Very good. Well, okay, too bad. Because what should happen is that it should not be able to be overridden on here or over here. But we'll just leave that aside, and maybe safety first. Safety first. And we have a on. Sorry, I meant fixed update base dot under fixed update underscore. Okay. Expression bodies. Yep. Right. Okay. Control C. You can just copy and paste that in here as well. Okay. Now we're done. Now let's get back. Oh, sorry. So over here we get the transform. We set the random values. Set valid random start position, which I should probably explain right now, and I will. One moment. Yeah, there it is. And yeah, there it is. This is a complicated function. So here it is. So we'll first get the radius, the game manager.I, the scale, sphere transform, local scale dot x. Here's the explanation. A game manager, we reference to a rotate camera tower. Oh yeah, right, I deleted that. find our references. 1. Very good. So we can get rid of it. By the way, that's same as in the CLI sphere. Okay, now let's get back to here. The scale sphere transformed at local scale dot x divided by 2. Oh, it's an extension method, that's why it's called this transform. Okay? So first we'll get the radius because it expects it to be evenly scaled. Okay? Then we have a return value. The return value is because magnitude. So we have a random dot range from x and none is z, flat on z and y. So x and z. Yes, this is z. Okay, and this x and z, like so. Okay, that's why minus radius and radius. Okay, and we clamp the magnitude, meaning maximum length is radius. It will just clamp the magnitude to the radius, and the transformed position to the return value, set value. Then we do physics dot overlap sphere, where we do an overlap sphere transformed position on it. And so first of all, this is to just snap it onto the position of a regular tile. Okay, if a radar length is not equal to 0 and a radar at 0 dot given to layer and grid. So first we check if it is not 0, and then we check, and also this layer should be game of grid generator dot instance and game of the layer, so that will be the same layer as the tiles. Okay, then we'll have the transformer position set it to array dot 0 dot transformer position, meaning it's now snapping it to a tile. Okay, that's what this is for. Got it? Okay, now let's get back to here, shall we? Then we have the claim starting tiles. I should explain all the extension methods, but here we go. Okay, so here we have a move based on directory. We'll have this transform and direction sided and speed. Transform at Euler angles. We'll set it to left 90. You can take a look at this. It is left facing, then we have 90 degrees, right facing. 90 degrees, left minus 90, up, left, goes up and into the left, 60 degrees and up and right, like so, and down and left and down and right. Okay, that's why that's the for. Left there's always a minus and right there's it's positive. Okay, and then we'll move in valid speed. Okay, we'll work on that in a moment. Now here this is very simplistic. Left 90, R90, U0 up and down 180. We're actually looking at it from the player's perspective, but from Unity this would be going up, not this. Okay, and we're moving in this direction. We're considering that as up because this is how I want to keep things here. Okay, we're looking at it from the player's perspective. Okay, and then over here we'll transform that move in valid speed, and over here we have two parameters, a transform and a float speed. And while we're at it, it is going to move hexagonal radius times vector 3 dot forward divided by 25. Where is standard delta time? One moment. Yeah, this is private. So move based on directory, find our references. Oh, no. Okay. So it's called unfixed delta. It should probably have a new parameter called delta time. But it works quite well and I don't want to mess things up. But delta time is something we should pass in over here so that it can work properly. But for now we can just go on with it as if it never happened, because It's just fine right now. Okay. And now we have to convert this to a direction 6-sided. If it's 0, then we return L, 1 right-sided, UL and UR, DL, DR and R. This is kind of to convert an integer to a direction. Okay. Same goes for here. Okay. So it goes like this: left, right, up, right, down, left, down, right, and this is for the default value. Then left, right, up, down, and then the default is R. Okay. And I'm done here. Okay. So we're done with that. Now with the extension method, so we don't need to explain that anymore. Now let's get back to it. Now we have a starting bonus, which I should again explain one more time. Okay. Now see, this is not like my original places where I explain it in order, but here it's quite interconnected. Okay. Also then last time. Then a radius of how big it should be, and on it will just draw a wire space so that we can see it very clearly. Okay. Oops. And we have a collider, array of colliders, and then we'll do an overlap, so transform position and radius, and then for each collider we'll try collision vector, and then we'll destroy us as in the starting ones. Okay. So we can't give it as a player. Got it? Then if it is the same as the game object that we'll here, then we'll have it as a tile. We'll check if it's a game object, so long as it's actually a tile, and then we'll get a mesh on it, and then we'll get a character. Transform a parent game object dot get component a character. Okay. So now two steps. Okay. And then we have tile dot mesh dot material, so long as it is not equal to character dot my material, and then we'll loop through all of our enemies, and then we'll set a tile mesh dot material is equal to the enemies, and we'll decrement the enemy score and we'll break out of the loop. Okay. Once we're doing that, we'll set the tile mesh and its material will set it to character dot material, and we'll increment the character score, and last selector will set it to time dot time. Okay. Let's get back to here. So starting life slider dot value will set it to life, and life display dot text will set it to string dot format string percent. Yeah. Okay. And so that's a format string for the life. I'm not using string interpolation here because I want to coordinate everything. Okay. And over here we have a last collect time, which will give you, of course, a last collect time. I mean, that wasn't that surprising. And then we'll have time return time minus time between collects times 2. So that it will get more time to collect everything. Okay. And then we'll have a move based on direction and speed. Otherwise, if it is touch mode, otherwise if it is not touch mode, then we'll do direction and steady. Okay. And transform dot parent, not actually parent, but oh yeah, one moment. Life slider and its parent and its parent. Life slider holder. That's right. Okay. And we have a NIFE and SLIDR and 2LDR. Life slider holder. And instead of getting it multiple times, I doesn't recommend we do it once. Okay. Okay. But that is impossible, so we'll have to do it in start underscore. And also we are calling start underscore start. Yeah. Okay. Then let's set the life slider holder equals to that. Okay. And then we'll have Euler angles equal to bit. Then we'll set its rotation such that it will be 90 minus, it will always be facing you. Okay, the player I mean. And change life will switch life plus equals by how much, and life center value equals life, and the text is equal to string dot format, and if the life is less than 0, then we call on that. I've checked method to check what to do. Okay. Increment score, this is just, regular old increment score. It'll just increment the score and then it will change the life and then it has a score display value equals score and then we'll refresh all the score display. Okay? Same here, we'll just decrement it and let decrement when error gets captured and refresh. Okay? And over here, we first check if it is a if we are hitting a play. Yeah, this just means that it is one higher as the wall. If that is so, then we'll just snap back, jump like that. Okay. And on hit edge, this is required in the enemy. Okay. The tile, we'll again get the tile and the mesh renderer, and then we'll check so long as it isn't our original. Then if it is and if the time is meaning it's just time for you to collect it, okay? That's correct time plus time collects, okay? And for it will loop through all the enemies and then will decrement the score and change our life by increment bonus when you're capturing enemy area, and then we'll break out of the way because you already found an enemy and it can't be equal to two things at the same time. Okay? Then we'll set the tile mesh to the current material and we'll increment our score and we'll set the last collect time to time. And if it is our own, so that's why on self tile. That's why it is called. Okay? Everyone's following me here, right? I mean, you are getting all of this. Okay, one moment. Okay, so where were we? Right, over here. So, what we'll do here is we'll have a target to follow and we'll have a speed of movement. Speed of movement isn't actually used anywhere per se, so you know that. Okay, the transform target. Then we'll record the start position and start rotation, and then we'll have a transform position and transform rotation. Just record them, and so long as they're not equal, so the transform rotation to the start rotation. Okay, because if it rotates in slight bit, we want to snap it back. Okay, and transform that position will set up the player transform. Oh wait, one moment. It's target position plus start position. Okay, major difference. Now with the camera thingy. Camera, where are you? There it is. Main cameras and player and game menu should always be at the top, along with canvases. Okay? Camera rotation control. And yeah, we do it from over there. This actually shows this is the thing that is actually controlled, not the player. That's one. Okay? One moment. Plus start position. Actually, target. We just set it to the target position. Plus start position. Okay? Because it is following it, and the rotation will just snap it back. Okay? Though, frankly, no, this is it. This is perfect. Okay? But the reason for all this is to reduce the code footprint. Okay? Large code footprints are generally bad. Okay? And now let's get back, shall we? And here we just have a few constants. Okay? You know what? I think we can also remove these stat rotations here because I don't think they're very much required. Okay. Pushing bodies. Okay. See very little code footprint, which is very good. Okay. Now let's get back to here. We're starting life. Life increment when capturing free area, meaning area that's not been captured by anybody else, and life increment when capturing enemy area, when area gets captured, and we have a 4 max string. Okay. Now let's decrement. Okay. Yeah, direction 4-sided. Frankly, very unintuitive. UDLR. That's not very amazing. Okay. And same goes for left, right, up, right, down, right. That's it. Nothing big here. We don't even need to open it. Now we're getting to the interesting parts. Okay. We have the enemy, and over here we have a game object models, and we have a my materials. And now we are overriding the materials we had before. So my materials at index. That's what we're doing. A switch direction timer. And we have a k underscore backing underscore index. Yeah, this just like so, okay? And if it is null, then we'll set it to integer.parse, give it a name, and then we'll get the value, okay? Finally. Got it? And a static enemy for all enemies will find all the objects of type enemies because there might be one or two that are, yeah, that's on that. One moment. You've seen my long-standing tradition. You probably know this works. Private, static, Z, underscore, all enemies, and enemy array equals so over. Yeah, we can do that. Okay. All enemies, and on die over here. And if you're destroying the game object, well, actually let's keep it on destroy function on destroy. Let's convert this into a list. One moment. Let's have it as a list. And I have still list of A characters, all the enemies. Okay, that will make things much simpler on this other side. System of collection is generic. We'll have to change a few things in the player, but I'm sure they're all handleable. Okay, all enemies. Underscore list of enemy, all enemies. Same here, we'll convert this into a list of enemies. Construct a, actually let's not do it over here, okay? And we'll actually do it when all enemies is accessed. It should be suitable time afterwards. All enemies equals find objects of type enemy, and then we create a new list of enemy. Let's actually convert it to a character. Okay. Now we'll have a list of a characters. Clear I, of course, we'll need to make a few changes over here. New list of a character. It's just a one line. It's just a one thing. Okay. Oh, one more thing. And on destroy, we'll have all enemies dot remove this. That's it. It will find all the objects of enemies when we access it, and of course this one is about to be destroyed, but it will most likely be accessed beforehand as well. And then when we're dying over here and the enemy dies, we'll remove ourselves as in the enemy from it. Okay? And now I have a direction study. It's more complicated than that. See, first we'll check if it is a random range 4 to 1, meaning it has 1 in 3 chance. It will just follow the direction. Otherwise, it will just take a random boolean value and set it up left, upright, and up, left, and upright, right, up, left, and right. I just found it by trial and error, and this is the thing that works best. So no need to discuss it. Okay. Much easier here. It is just one in an a 1 in 7 chance. It will be a standard direction, or then it will check in 0 to 4, 0 to 3, and then convert it to a direction 4-sided. Okay. Okay. Now let's see. Over here we have a start. We'll loop through all the modules and set them, turn them off, and then we'll turn off the one at our own index. And then we'll get the maximum value to generate a tile number. This is required for some other reasons. The set random direction. We'll construct a new randomized timer from 2 to 0.7.5 seconds. Then I'll switch direction, and then we'll have a start. Okay. Last collect time, again same thing. Okay. Hold on a moment. List of a character. Okay. List of a collection. Okay, we're done. Now, let's look over here. I just very recently, yeah, we already do that, so we can get rid of this. Okay, bye bye. And hopefully you don't have that here. Okay, never mind. And then we'll just set the random direction. Direction is done. Again, more randomization, which makes it really more random. Fixed update will just call fixed update, and update will call on update. Switch direction timer time. Okay. And then we have a on collision enter. We'll call base dot on collision enter collision. Okay. Then we have a on die, on hit edge, on self tile, set direction both, and we'll destroy our game object when it dies. Obviously. But player has to do something else. For example, I don't know, triggering a game over. Okay? That's fine. If a random boolean, random 0 to 0 and 1 is equal to 1. Okay? All the players, if it is, and just like so. Okay? We have an underscore player, and we have constructed a new list of characters, a character, and we'll have it as a player type. That's it. That's the only item in it. But a character demands, so we'll have to give it just like that, even though I created it. Okay. Now moving on. I've already explained extension methods, so no need to go over it again. Game manager. This is the thing that might again take a while. Okay. And over here we have a UPB, if you're wondering what that. Oh, one moment. It's a good value. What is it used for? One moment. Absolutely nowhere. So you can get rid of it. Bye bye. And open up game manager in quite a while. Okay. Play screen, game on screen, and pause screen. All this is UPB. Unity public, meaning it's a serialized field. Okay, just shorten it. And also this is possible, you can assign it like so, and we're using static constant, meaning everything as a constant is it's on. Everything static and constant is directly accessible. Okay, got it? Like generally over where is it? Oh yeah, sorry, I got it in the calendar. So usually I have to do like constants dot life increment when an array gets captured, but we're using static constants, meaning you can use all the static fields just like normal function that we have in C++. It's a default in C++, by the way. Okay. Now moving on. We have a game object and game over screen and pause screen and underscore scale sphere and touch mode toggle, and then we have high score text display. The new high score text display. Use this to show the high score in percentage. Use this to show if the player has achieved a high score in the game, typically while showing the game over screen. Okay? And score text display. Player's current score in percentage. Okay? And we have mobile touch buttons, meaning all the 1, 2, 3, 4, 5, 6 touch buttons. These guys. Okay? Then we have a score, which is equal to player.i score times 0 100.0f. We have to convert it into float, and then we divide it by the generated tal number. Okay. You know, we should probably keep it as a separate value here. Somebody else has created it, but then again, I know this is highly unoptimal. Int, it's not nullable, so we'll have to keep like underscore GNERITD dead underscore TIT tile NUMBR dead. Okay? And you probably know how this works. Okay? Question mark or null coalesce, meaning if this is null, then return the thing that's over here, otherwise give itself. Okay? And one last thing, dot value back, and we are all done. Okay. So game manager, and that should simplify things much more. Okay. We have a scale sphere, which will just give you the scale sphere, and then our timer time scale is set it to 1 because we do the timer time scale. And we have a mobile touch button, just set that active. And toggle touch mode toggle that is on will check it. Mobile touch button will turn it on if it is a touch mode, and then we'll set it back to the touch mode. One moment. Then see, much easier. Oh yeah, we're using format string. And we can't really do it using string interpolation in a simplistic way, but doesn't hurt to try. Okay. $sign done. Okay. This really doesn't simplify anything very much, but then again, you can also do it like that. But I don't think this is optimal here, so this is good for us. Okay. And the set screen on. We set the screen state at play screen. I should show you the format string. It's very simple. Format string is 0:000.00. Or this means the first will format in a 0:00.00. This is, by the way, as a digit as a digit. So we have, if you have like 4 digits and 1 moment. If you have 4 decimal places on the left side, decimal places, and if you have 2 over here, so let's go 1, 2, 3, and 4. These two, only the first 2 decimal places. The rest will be just discarded because that's how we are formatting it. Okay. And then we'll set the screen and play screen, and we'll just set the new high score text to the game over. And over here we do it slightly differently than we did it in PT. Okay. And then context menu game over is, we'll set it if it is a new high score. Restart game, we'll just load the level again. Pause, will turn on the pause screen. We'll set the play screen on. And we have a screen, we'll set active. We turn all of them off. Then if it is a play screen, we'll set the time return to 1 and then we'll set active done. And then we'll turn those to 1. Okay? We'll set it to true, return on the play screen. Otherwise, if it is a pause screen or the game over screen, we'll set the time return to 0 and then we'll set it active. Otherwise, we'll just by default set the play screen active. Let's set this as the default, right there. Okay? There. Yes. Set touch mode. This is just for setting the touch mode whether it's on or not. This will remember whether the touch mode was last set on or not. Then we'll reset the high score again using the string.format over here. Then we'll reset the high score and we'll again set a string.format format string placing and percentage. This is just setting it again. Okay? Refresh the current score text display. I should be consistent here. Yeah, you know what, let's switch this, okay? So score, spacebar, like so. String dot format. Format the score using the format. Oh, sorry. We'll format the format string according to the score. Okay. Then we'll just call cmanagement.quit if we have to quit. Okay. So, oh, it's an 84 line. That's short. So, I guess that concludes all of that. Much better than the previous game managers. Okay. Now let's get back to the player. Should be fairly short again as well. Okay. Let's get back to here. Our game manager fish models and then my materials. One moment. Fish models and we have my material and score tail the fish changes. Okay. Where my material just use it, and direction actually this is more normal than usual. And then if direction std equals to value, then we'll return. Otherwise, we'll set the enemies of direction std equal to the value, and then we'll set the direction std to the value. Finally, at the end, same goes for here. We'll just set it enemy direction equals to value rather than direction std. Okay. Then score till change timer goes like that. A player instance. This is just as an singleton implementation, as if you've always seen the template class singleton. But the thing is, C# does not allow inheriting from multiple classes, which would be amazing. But of course, C# doesn't allow it. But there are two languages which I would like to point your attention to: C++ and Python, which do allow it. Okay. And then there is a boolean has started, so as the game started it, and then we'll have the base to increment score. We have to do something else, that's why we're overriding it. Then we'll increase the timer, and if it is time for us to change the fish, then we will set the timer back to 0 and we'll change the fish. Okay? Oh, sorry. Then change fish, it will just call for each fish model we're turning off, then we'll get a random fish from the fish model or get an element. We'll set that active, and if it has not started, then it will return. Otherwise, it will speak the Windows voice. It will call Windows voice to speak. It will call randfish.name. Okay. By the way, I've updated Windows voice.dll and I'll show you the updated one when I do. Okay. Then we have the enemies. We'll find all the enemies. This is conservative because enemies has a smart method of getting them out. Okay. Now have an on collision enter, meaning when it collides, we'll call based on collision enter. Otherwise, if it hits an enemy, then we'll call game manager game over. Okay. This will happen 2 times, either if you lose or your life, which is very unlikely, but it can happen. It did happen once. Or if you hit an enemy, which is the most likely of all. Okay? Start, score display or max value. Okay. Yeah, I see some common code around here. Let's move that. Okay? Start underscore. Oh, sorry. And see, that's a common code, and that's why we need to segregate it out. I was segregating out the common code. Then we'll set the base start. That should be the very first thing we do. Then we'll set the hash started to true, and then we'll change the fish. Okay. Oh, one moment. After we call change fish. That's the whole point. And then if it is on the update, then we'll first check if it is on touch mode. If it is not in touch mode, then we'll do maxf.round input.get access raw left and round to int. Yeah. So this is left, right, and up, down. This just really is much more intuitive than the other names that they gave. This is much more intuitive. Okay, I'll show you what has been right about now. Okay, so I created new axes, 10 different axes. Well, not just many of them. A, B, X, Y. 4 keys on a gamepad. I have one of those anyways. If I left, which just gives you the joystick axis, the regular old joystick axis, left, right. Then we have the fourth joystick axis. Again, we're keeping them all left because that's just how I like it. Okay. Then we have the left, right, positive button, alt negative button, D, and alt positive button. Left, and right, A and D. Okay. You probably know about all of this. And then here, fifth joystick is the one on the right, and the regular one is the one on the left. Okay. Yeah, like that. And then we have a S. Yeah, we have up and down. Okay. Yeah, due to some reason negative needs to be the down button over here to work. So I should set this to but the negative needs to be the up button. So W and S. Good. Up needs to be negative and down needs to be positive due to some reason. But this is just how I need to keep it. Okay. If it is 1 or -1, then we set it to direction dot four-sided R. Otherwise, we'll set it to left. And if it is case 0, meaning it's 0, meaning you're not pushing down left or right, meaning it's either you're not pushing down left or right, meaning it's you're pushing it like that. Okay. Then we have a default case, meaning now pressing, or if it is 0. Okay, meaning if it's anything else. This is highly unlikely, but if it does occur, then this is what we'll do. Then we case 1, and we'll case -1 of U and D. Oh, and I should mention, never, and I really do mean this, never ever in your entire lifetime ever use mathf.sign. Never use it in your entire life or you will get into serious trouble. You know why? Because math.round, sign of, I don't know, 0 would give you 0, but mathf.sign would give you 1, which of course you all know is very wrong. So no thank you. Okay, so don't use mathf.round, I mean sign. Round you can use, don't use mathf.sign. That's very evil, trust me on that one. Okay. don't use it. I ran into trouble when I did that, but then I rechecked it to check if there was something wrong with site, and turns out there was. Okay? And now we have fixed update underscore. We'll just call the a character at fixed update. We can just call that, do the movement, and set the new Euler angles. Then set left, set right, set up left, up right, down right. Just set the respective directions, and on die we call game manager at the game over. And if we hit the edge or if we hit the self tile, what do? Absolutely nothing. Okay. Now, if you're wondering what those are called from, then arrow scalar and set left. Okay. Set left, set down left, down right, up right, and right. Right? Okay, got it? So that concludes the player. Now screen state. Why did I open that? Anyway, this is very small and simplistic. Just play screen, pause screen, game over. Just 3 screen states. That's it. And then we have a starting bonus. Oh wait, I already explained this to you. Okay. So that concludes the game demonstration. That concludes the code explanation of the game for Infiltration. So I hope you like the game. I hope you like the explanation. And thanks for watching.